Dinner. Samal Damakam. Can you hear me?
Sama.
Very good, very good. I mean, how many do I expect participants? Is there anybody doing it, two of them are one place? We see 18. If I remove myself and Mr. Das, there are 16, 4 to go, right?
Yes. There was some internet connection too.
Okay. Let me know when it is ready so that we can start.
Okay, guys are connecting with their data. I think you can start.
Yeah, can you confirm if we can start? Can we go ahead or we wait for the last guy?
I think we can start, Chief.
Oh, right. Okay. Oh, thank you, Dale. Salam Nachu. Good to hear you guys once again. Very good to be here. I'm doing it for the first time on Zoom, the training, so I might have a slight hiccup. So if you cannot hear me properly, you have to be with me for a while now. Code on the cloud. Okay. All right. Okay. Just give me a signal that everybody is hearing me. I mean, how do I know? I mean, everybody okay? Everybody can hear me?
Yes, Chief, we can hear you.
We can hear you.
Very good. So anyway, so good to read you guys once again. And I know that you guys have got some small questions for me. I'll give you a few minutes at the end of the session so that we can have a small chat. So we'll do that one. So I'm given 3 chapters for this MML last 1 month course. I'll be dealing with chapters 17, chapter 18, and chapter 19. All 3 will be safety related, so nothing technical. I know it's going to be a little bit tough, but you have to be with me. What you guys have started already chapter 17, I've been told, starting from hazardous to enclosed spaces up to breathing air apparatus and escape sets. So what I'm planning to do is that I don't know, I haven't seen the whole content of the book, but for me to go smoothly, I will change the pattern a little bit differently. What I will do is I will start a little bit from chapter 18 which will allow me to deal better on the enclosed spaces and the permit to work and other dangerous or safety related permits. So I'm just sharing you. Can you see the shared screen properly?
Yes, we can see, Chief.
Good, very good, very good. So what I'm doing is that, I will stop dealing with enclosed space for now. I will go a little bit further back to the permit to work and risk assessment. Then I'll come back to the normal flow to the enclosed space and hot work permits and the other permit requirements. So, but even before I go further into the enclosed space, I'll take you a little bit back one step. You may do it in some other chapters, I'm not sure, about a little bit of ISM, a little bit of safety management system, so that we'll get the overall picture what we are dealing with. When it comes to this particular safety subject, I don't expect you to get it much on the written part, but definitely will be asked in the orals in more details. And most of you, I'm sure all of you have done out fourth engineering, third engineer, and from now on, you'll be, of course, definitely, you'll be at the second engineer, probably on small ships as a chief engineer. So your perspective when it comes to these permits and checklists and SMS and ISM, the perspective will be different because earlier you were in operational level, now you'll be on the management level. So you'll be the ones who will have to explain for you juniors how to do it, and you have to be very well familiarized where it came from so that you can understand it and exploit the best out of this course. So earlier you have seen, I think you have done it with Mr. Bose regarding enclosed spaces. And when you see enclosed space, you have come too close to the enclosed space permit, but I'll just talk to you about what the permit is, where it is coming from. These things, they become more prevalent and they become more of audited requirement as per the induction of ISM in 1998. And this one of the requirements of the ISM requirements, as you know, is one of the basic requirements from ISM is for all companies and every ship to have safety management system. And this safety management to hold whatever is you need to do on board the ship as a document, all the permits, all the requirements, and it will be a very good reference, and the reference you'll be using whenever you do whatever you do on board the ship. So I'll try to come from basically from the ISM, SMS, and we'll come to the permits reflected, how it is reflected on this document. So we'll start with the topic saying that management of safety and emergencies. And at the end of the course, I'll give you, of course, the references I've used. Probably you'll have it at the back of you, on the back of the book you have which references we have used, but this particular two documents I have used, I'll share it with you at the end of the course. All right, when it comes to management of safety and emergencies. So, sorry, this one is a mistake. The international, the ISM code. The ISM code, like I told you, it came in 98. This is actually trying to cover all safety matters when it comes to the shipping industry. So what the ISM code says that under the ISM code, safety management processes are based on risk assessment and risk management techniques. This is a significant difference from the approach from the previous one. What it is, the previous to the ISM, actually, we used to have compliances. That means they will give us a document and we comply that particular document as it is stated on the documents. But the ISM says that actually if the safety has to be taken care of properly and for it to be continuously improved, we have to approach it in different scenarios. So they say it has to be with an assessment. The risk has to be assessed and the risk has to be managed, and they give us a tool how to do those processes. So based on that one, what they have said that the purpose of the ISM code is to provide an international standard for the safe management and operation and pollution prevention. The code requires that the ship operators should be provide for the safe practice in ship operation and safe working environment, establish safeguard against all identified risks, continuously improve the safety management skill of personnel ashore and aboard, including preparation of emergency related to safety and environment. So it comes into three categories. That means provide safe or practical operations, practices in shipping operation, and establish safeguard against all identifiable risks, which we have to identify and we have to safeguard ourselves against. And these things, like I said in the previous one, it was a compliance, but this one, instead of being compliant, it is actually continuously improved after studying it by suggesting for improvement, and it will continuously improve, and it makes your particular vessel and your industry more safer as we go along. So this is what the ISM is giving us a tool for us to protect ourselves. So one of, like I said, one of the main requirements for the ISM is that the code, it defines that a ship operating company requires a company to develop SMS, which should include certain functional requirements, particular instruction and procedure to ensure safe operation of ships and protection of the environment. So it makes it a requirement, ISM makes it a requirement that every company, and actually every ship in the company, should have specific to that vessel an SMS. And this SMS, actually the one which is giving us instruction and procedures to ensure safe operation of ships and protection of the environment. So the reason I've come to the ISM and the SMS is because beyond that, our topic is actually how to go about risk assessment, permit to work, and this permit to work to individual works like enclosed space permit, auto work permit, this one. So when you see incoming enclosed space permit, for example, that permit, it should have a source. The source, as per you when you go on board, that document has to be referred in the SMS. SMS will give you the whole guidelines how to use that particular permit. Even if this SMS is giving you a doubt, if you are asked, if you have in any way, I've got a doubt in it, that you can go back to the SMS, how the SMS is actually instructing the SMS to come, and how the SMS is giving you these tools. And this one goes as we work, like it says here, it is that one of the third and critical point of it is for us to continuously improve at the ship changes, as the scenario changes, as the environment, as the situation change. Our approach also needs to change. It has to continuously improve so that the SMS at the end of the day will be able to cover all, imaginable risks and scenarios. So this is how it is. The SMS gives out the instruction procedure to ensure safe operation of and protection of the environment. So like I said initially, instead of being compliant before the ISMS, this one, the ISMS is not a prescriptive as such. They don't prescribe you how to do what to do. But what it says that it is with regard to how a ship is managed, it is left to the company to develop SMS elements suitable to the operation of specific ship, not specific company, specific ship. So you will have a specific SMS for individual ships, and it's not a prescriptive, it is a continuously improved document. That's why actually when you go on board, particularly when you go on board as second engineer, you'll be asked to make a note of accident, near misses, whatever this kind of scenario. So all these accident, near misses and all will come back to improve the SMS so that the SMS improves continuously and your permit works in the same time. All right. This is this is a particular how the SMS is coming towards the SMS to give us the tool to create our continuously improving documents. Can you guys hear me clearly? Am I audible enough? Am I the pace is okay?
Yes, if it's clear.
Good.
Yes, Chief.
Very good.
It's okay, but can you
Yes,
the slide full screen?
On my side, it is full screen. Now it is half screen. On my side, it is full screen. Now it is full screen. Can you see full screen?
Yes.
Okay.
Okay. I mean, okay.
Oh, I understand. You mean
Sure,
say this one?
Yes.
Let me, yeah. And wait, I'm changing it. Yeah, I understand. Yeah. Like this, you mean?
Yes. Yes. Now it's okay, Chief.
Yes.
Good. Very good. All right. So now let's go to the safety management system. ISM gave us the safety management system. So the safety management system actually enables effective implementation of the company health, safety, environmental protection policy. This is actually the main 3 points the SM is trying to give us. So the SMS is subject to regular audit to verify it is suitable to deliver the expectation of the ISM code and to confirm that it is effective and standard procedures and all. That's why you guys see the ISM audit every year nowadays, because they come on board actually to see that the ISM requirement has been implemented on the vessels. So one of the tools, one of the means they see is that actually they will inspect your SMS, in whatever form and circumstance you have, whether it's hard copy, soft copy nowadays, more or less in soft copy. That's why they ask for, when they come on board, they ask the second to show them the previous enclosed space, the previous work permit, the previous, whatever you have done, they will check it. They will check the document just to see that actually it is as per the minimum requirement of the ISM, and the SMS is actually covering all the known health, safety, and environmental risks the ship might cause. So this is how it is done. So the reason it is it is audited actually in any improving system, it has to continuously improve. So this auditing actually, why they're coming on board, is not as such to punish the vessel and to detain the vessel. No, that's not the main idea. It's actually, agreed upon and implemented by the whole industry, so that the industry, by auditing and finding the continuously improve, and whatever accident and incidents we used to see pre-ISM, that the ISM came because there was a lot of accidents happening, particularly in the early 90s when particularly the oil industry booms and there were a lot of accidents. So they want to reduce that accident to the minimum. So they came to the ISM and SMS, and to make sure that this ISM and SMS is continuously improving, they make sure that there is an audit. So why I'm repeating it a little bit more frequently is actually, this probably will be your baby when you go on board, because you are the ones who will be in charge of maintaining and making sure that these documents are up to date and they are meeting the requirements of the SMS. And as we go forward, we'll see actually what your specific duties could be on this regard. All right. So the SMS is subject to an audit. It will be verified by suitability to deliver the expectation of the SM code and to confirm that is effective and that standard procedures have been followed by everybody concerned for different types of permits. So on this regard, for you to make it easier, for you to stick to the regulation, to stick to the SMS requirement, the SMS tells it must demonstrate that it has covered all the acceptable level of safety management are placed and to protect the ship personnel and the marine environment. That means it has actually should be able to cover continuously, fully. So to deliver the required level of safety, the SMS will need to be addressed all activities undertaken in the operation of the ship, together with the possible situation that may arise which affect the safety of the ship or its operations. I mean, like you see. Yes, anybody? All right. So the SMS, it is different from ship to ship, but I mean, some of the companies in general will have a standard, but when it comes to different trading pattern and type of cargoes, the SMS will be different. I do expect the SMS for the container will be, I mean, much different from what you might find on tankers. And the same when we go to bulk carriers or car carriers. So the SMS, that's why it becomes specific to a particular vessel. So this SMS, it should try to exhaustively cover all activities which could be taken on board the ship, all activities in the operation of the ship, together with the possible situation that may arise which would affect the safety of the ship in operation. That means together with, I mean, imaginable scenarios, even if we don't face it we don't operate it in continuous and periodical level. I mean, different accidents could happen, like grounding, collision. All these scenarios also have to be covered in the SMS, so that in case it happens, you'll be ready. You'll have all the risk more or less covered, so that you can protect the environment, protect the vessel, and most importantly, protect yourself. So that's what the SMS is trying to do in this regard. So these activities will be very different one from the other, and because of the nature of difference and the hazard they pose to the vessel and to the person environment also will be different. So since that is the case, careful assessment of this hazard and probability of their occurrence will determine the severity of the risk. So you'll have to see, I mean, the risk assessment you have for your bunkering operation and the risk assessment you have for your hot work permit, of course, will be different. So, and the hazard they pose will also be different. For example, you take, bunkering. On bunkering, you will be more worried about risk involved on the environment, not rather than the personnel. But when it comes to the hot works, I mean, that will be more or less, will affect more onto personnel, of course. I mean, if you are welding, in tanks and holes, that might also cause environmental, but in an immediate nature, it might involve more of, personal risks. So these activities situation involve varying degree of hazards to the ship, its personnel, and the environment. So careful assessment of this hazard and probability of their occurrence will determine the severity of the risk involved. So we will be involved into the risk management tools we have to use. We will see, a slide or two after this one, how we deal with when it comes to risk. So risk management tools are then applied to the safe completion of the work, to ensure compliance with the SMS, and to provide the objective evidence needed for the verification. So for the verification also, we have to provide subject. So what it says that one of the important part to see here is that the risk management tool, it has to give us, we should be able to comply with the SMS. And when we record, because like the SMS says, the three critical points, what the SMS is saying, that when it comes to this kind of situations, you have to plan whatever you are going to do. And the planning has to be thorough. And once you make your planning thorough, they expect you to follow the planning. That means you do as you planned, not to go up beyond the planning, because once the planning is exhausted, you follow the planning. So you plan and you do other plan. And the third part, which is maybe in your case more important when it comes to auditing, will be objective evidence collection. That means recording part of it, so that you can refer it and you can show it for the third party when the auditing coming on board, so that to show that you are actually following the SMS and the ISM requirement. So all three parts will be very, very critical when it comes to the ISM, and particularly when it comes to your particular duties. All three will be important, and for the third party, your recording will be paramount importance. So the SMS will give you different documents. Actually, basically, they are split in two. One is, it gives you document and policies, gives you what you see actually company policies. You probably have, each one of you probably have in your companies 5 or 6 company policies, like health and safety, environmental, about training, like that. I mean, IT policy, 5 or 6 policies will be there. These policies are the ones which are actually further described in that particular document as how you can translate your day-to-day work into the company's policies. They will give you a day-to-day jobs which you'll do. I mean, like the permits and checklist and the procedures, they will be reflecting the company policies ultimately. So just to sum it up, the end result of an effective safety management is a safe system of work. That is the main point of it, to create a safe system of work. That means protecting, primarily your own safety, your vessel, and the environment. That basically is actually, the background I like to give you regarding when it comes to the ISM and the SMS. If you have any questions, you can raise your hand. Otherwise, I will proceed to the next one, which is the risk awareness and risk assessment. Like we said earlier, actually, when it comes to the ship, it is full of risk. There's nothing we do which does not involve any risk. What we are expected to do as an engineers or as responsible persons is that we have to be aware that there are risks, and these risks, they cannot be avoided, since we have to move the vessel, we have to do the day-to-day work. But the only thing we have to do is actually manage the risks. So I'll start with what it meant by risk awareness. If seafarers are fully informed and aware of the risk to their health, safety, and welfare, they are much more likely to ensure they avoid the risk and remain safe. This knowledge is obtained through risk assessment and in other ways through our lives, including training in theory, practical application, information, observation, instruction, supervision, and personal experience. We can improve the quality and usefulness of information available by effective knowledge management. So this is what we do actually to improve the quality of our work and the safety of our jobs, by actually pay attention to the risks which are involved, to be aware of the risks and how we can manage them and minimize them, since we cannot actually eradicate or avoid them. So when it comes to risk, before we go into the risk management details, we'll see the terms and how risk is actually understood and made into a document so that we can put it into use. So one of the main and a frequent word you will hear when it comes to risk or risk assessment or risk management or risk awareness is hazard. What is hazard? Hazard is potential source of potential injury, a source of potential injury or harm or damage. It's not by itself actually a damage, an injury or an harm, but it is potential. If you don't manage or control your risks, you might end up having an injury and harm or a damage. But hazard by itself is not actually any of this. So it is only a potential. So it may come from many sources. The situation, the situation how we are dealing with the particular task, the environment where we are carrying out this task, or the human element. Human element means how we are doing it by ourselves, how we are qualified enough to do it, or maybe the proper tool we use, the proper procedure we use. So this human element is the one which is, as I'm sure you know, I mean, when it comes to our industry, most of injuries and accidents, they happen because of human elements. So this human element becomes very, very critical when we actually are trying to reduce whatever risk we may face. So that's how we approach, that's how we understand. So one of the terms we use more frequently is hazard. We have seen what it meant. And yeah. Yes, sir. You guys are there, right?
Yes, we are here.
All right. The good thing about Zoom is actually, yeah. Any questions? I hear something at the background, but I'm not able to catch it.
No question, Chief.
All right, I'll proceed then. Good. Risk has two elements, they say. That is the likelihood that the harm or damage may occur, whether it is there is a possibility for it to occur. And the second is the potential severity of the harm or damage, if at all it occurs, if we allow it to occur. Sometimes we may allow some of it to occur in case it is unavoidable, but we have to make sure that the severity has to be reduced to a level we can accept or we can manage or we can control. I mean, that's how we do it. We'll see about how we go. We'll take examples and we'll see how actually we reduce the severity of any harm or damage. And the likelihood, the same thing. The likelihood of happening an hazard, we have to reduce it to the minimum so that it doesn't happen. Even if it happens, it actually happens very rarely, or it should not be likely to happen or very likely to happen. We have to make it so we have to minimize it in such a way that it's happening is to the minimum. So by these two terms, we will hear it more frequently when it comes to risk. I mean, is it going to happen? Is there any chance for it to happen? If there is, what do I have to do so to minimize that happening? I'll give you an example. I mean, a simple example. Let's say we go for a welding into bunker tank. So when we say that, if I go into a bunker tank or diesel oil bunker tank and I've got a hole, I have to weld it. So if I don't do any tank preparations, whatever is required, which you know practically, if I try to do any job on that one, whether it is cold work, hot work, and the likelihood of happening fire will be very high. So it will be actually suicidal to do that without actually reducing the likelihood of happening a fire happening. So we know exactly what to do to prevent that one. But if you happen it, for example, now, if you allow it, what will be the severity of it? So we say that it is actually, if we do hot work in a diesel oil tank without the due preparation, the likelihood of fire happening is actually very high. So we increase the the likelihood of it happening, and we have to see the severity of it. How severe, if you allow it to happen, if you have to do it and we do it, what is the severity of it? We can imagine the severity of it, this one will be very, very high. It will be, I'm sure there will be fatality involved, loss of ship, pollution of the environment, blah, all those scenarios will be there. So when we go to the risk matrix, we'll see this will give us actually a red flag, not to allow us to do. So that's how it is done. So these two critical points, if you take care of these two patterns, if you reduce the likelihood to the minimum, if you reduce, even if if a damage or occurs, if the harm or damage occurs, if you reduce the severity of it to minimum, then you might be able to do the job. But these two particular terms, or these two particular situations, we have to watch them very closely. That's why it will come continuously and frequently when we do things. So what is a key tool in ensuring that all involved in the work have a clear understanding, awareness of any other and their associated risk, is carrying out a toolbox talk before the work commences. Now, it's not the only one, but it is one of them. Toolbox meeting, that means this is to understand actually we have done the risk properly. When after the risk, as you know, when the permit work procedure will come. So having this risk assessment, the permit procedure, then we'll go on the toolbox talk to make sure that everybody is on the same platform, everybody is on the same page, so that the possibility of the likelihood of the harm and the severity of the harm have been reduced to the possible minimum under the situation. So, in addition to what we say, the SMS, the ISM, and those requirements, it is very important that the application of knowledge in the workplace is influenced by our values, beliefs, attitude, and behavior, and by the view of the others. This is facilitated by ensuring a safe working culture. What makes the shipping industry so complicated and so full of incidents, its accident, is because on a particular vessel, you see people from different parts of the world with different values to life, with different beliefs and different attitudes to different situations, and attitudes and behavior to different situations, and people actually how they live, how they are viewed by the others. These things affect quite a lot on top of the procedures and whatever documents we use. So this makes it actually difficult for the shipping industry to create a standard sort of, standard approach towards values and beliefs and attitudes. We cannot control it since it is actually an international market. What you might find in a particular location, for example, in Bahardar, people from Bahardar, in a particular industry, you might expect a particular values, beliefs, attitudes, and behavior. But if you are thrown into a boat in the middle of the ship, people from Philippines, Poland, and God knows where, and you don't expect everybody to have a similar attitudes, beliefs, and behaviors. So what the shipping industry or the ISM and the SMS is trying to do is for each company based on its SMS and each vessel by its own effort of knowledge and workplace influence is actually somehow to create and facilitate, ensure a safe working culture. That's why this one is continuously coming. You hear it that saying that we should have a safety culture, safety culture, safety culture. That is when it comes to, I'm trying, since because we have in different, different scenarios here, different beliefs, values. So some sort of, common ground we have to establish when it comes to the international shipping. And this is what the struggle the ISM is trying to win by establishing a proper ISM, by auditing it, by improving it and giving it a standard so that we see less damage, less days, and less pollution, which I can tell you, I can assure you that, I started sailing from early 90s, and the number of the vessels throughout the world have maybe tripled or quadrupled since then, but the accidents, percentage of accidents have drastically changed after the establishment of ISM and SMS and the rest of checklists and permit to works. So it did actually a very, very good benefit to the industry. And we have seen a reduction of accidents and incidents. And we expect this one to minimize even further. I'm sure that, you might have seen on your ships, the company KPIs, when you go on board, they'll give you what kind of key performance indicators. They call them KPIs for different vessels. If you closely see what are the KPIs for pollution, KPIs for personal injury, KPIs for grounding, nowadays they put it literally zero. They don't have any room for us to make mistakes. For that not to happen, they will tell us that you follow exactly what is written on SMS. And you as a second engineer or chief engineers will have to make sure that, this has been thoroughly followed. So, before I further go to the permits, so every permit, as you know nowadays, it is preceded by risk assessment. Nowadays probably it might have come a little bit of a nuisance because every operation earlier which has been considered to be a routine job, that also needs to be covered with a risk assessment. The company I was in, I don't know, probably most of you will be the same. When you do, cylinder head removal for main engine used to be a common thing. Now, it has to be preceded by risk assessment. So they say because, there are still accidents happening when this kind of even routine operations are done. So risk assessment is important. So that, that has been minimized to the KPI of the company. So risk assessment is a critical part of your job, probably as a third engineer. It will become more so when you become a second engineer and chief engineers. So risk assessment this is an assessment, a process to identify the hazard. We said hazard is only a potential, it's not a damage yet. Present in a work undertaking, analyze the level of risk, actually how bad it is, consider those in danger, and evaluate whether hazards are adequately controlled, taking into account any measures already in place. So like you see, hazards are adequately controlled, not eliminated. We can't eliminate it. As long as we weld in the diesel oil tank, whether you wash it with whatever means, you can only control it. You cannot eradicate it because not everything is under our control. We can only control within our realm. So still, it has to be only adequately controlled so that it can be taken care of safely. So this risk assessment is taking into account any measures already in place, whatever you have placed already, and maybe the construction of the valves, the equipment you are working on by itself may have provided some precautions. But on top of that, I mean, look, as you've seen initially, the environment also could change, the situation might change, and the human factor might change. So in addition to the taking into account any measures already in place, all the other things also you have to consider how actually they are directly affecting the risk, and we should be able to adequately control it so that we can safely carry it out. All right, probably this probably could be common questions. I mean, when you are facing, I mean, orals also. I mean, if you are asked about, like I said, the example I gave you, cylinder head operation. I mean, people will not be that bothered about how you open the bolt-in nuts as a second engineer or chief engineer. I would really like to hear from you, to see from you how you actually see whatever we have discussed now. I mean, since from the beginning, because that is the approach which is extremely expected from you, not the bolt-in nut. But that is important, but the approach, risk assessment, and the risk management and permit workflow will be a critical part of the opening and the boxing up of the cylinder head, on top of the gasket, the O-rings, and the bolt-in nuts. So you have to make sure that actually, when you answer your questions, you have to keep these things in perspective so that you do understand what the job all involves in addition to the mechanical work. So we have what we call FSA, formal safety assessment. It's more or less a standard. This is what you hear when it comes to risk assessment nowadays. So it's actually common for any industry you go. It is the same thing. It is a systematic method of risk analysis that aimed enhancing of marine safety, life, health, marine environment, and property by control or mitigate the risk. Control or mitigate. So I mean, sort of actually, you're actually adequately controlling, mitigating, and controlling the situation. So they have a standard 5-step methodology, formal safety assessment methodology. So the first thing you have to do, of course, before in any relationship or in any situation, what you have to do is that actually, is there any hazard? I mean, is there any hazard? Unless there is any hazard, I mean, you don't have to go into the whole thing. So you have to identify the hazard. Then analyze the risk. Then you do a control option. Then you see cost-benefit analysis. Then decision making. I will slightly break it up to you, and we'll see it, but not into detail. Just see, I mean, for a basic, I mean, we can go to the tank, the diesel oil tank again. Actually, that will give us more variables and parameters, but we'll forget that one for a while now. But you just see, I mean, when you guide your own kid, I mean, actually, when you tell him that when you go on the street, make sure that you cross properly. I mean, that means when you tell him that, I mean, when you go on the road, when you cross the road, take proper precaution, means there is a risk actually. We are telling him that there is a risk. There is a risk, potential harm, potential damage. That means we are talking about, I mean, accident could happen. So we have to identify the hazard. That means that possibly there will be an accident or a damage if you don't tell him where to cross, how to cross, where to see, how to see. If you don't tell him, then I mean there is the hazard. I mean, what do you call it? The damage going to happen. So we have to identify the hazard. So we tell him that, I mean, if you don't cross properly, there is actually a chance of getting hit by a car. So we analyze the situation. Then how do we control it? Then we go, I mean, actually, when you cross from this one, you zebra, blah, blah. Make sure that the car is at least 50 meters from you. So we'll see that, I mean, actually, if that is mitigates it. Even when we do, I mean, this one, I'll go to a cost-benefit analysis. Sometimes when you go to the situation, now, I mean, I can tell you in the case of your kid, I mean, if you still, even this one is not able to do it, in the boy is a bit too too little to understand and to carry out all these tasks. And the cost will be too high to take risk, even if I tell him, because he had to start, the cost is very high. So you may have to avoid sending him in the first place. But you can take also, I mean, a tank, the diesel oil storage tank I talked about. So what you do is that, what is the hazard identify? What is the hazard actually involved here? I mean, a lot of hazards. I will not go into all details, but then these hazards you will see it in detail, actually how to minimize it. Then is it controlled enough? So even if I did all three, let's take for